Now this slide summarizes the MIMO modes used in the LTE downlink before we go in more detail on some of them. Transmit diversity is one MIMO mode. It is using a space frequency block coding scheme, SFBC, and that is used as an additional antenna coding. As explained on the slide before, the transmit diversity mode is increasing the robustness of the transmission, but not the data rate. So the space frequency block coding scheme will also be further explained in the following to give you an impression of what's really done there with the signal. Achieving the high data rates in LTE is possible by using the spatial multiplexing MIMO mode. Again, this allows transmission of different data streams simultaneously over multiple spatial layers. And to further improve the performance of this MIMO mode, a so-called codebook-based precoding approach is applied. That means the signal is pre-coded before transmission in an appropriate way. And this will be illustrated further in the following as well. There's an open loop mode and a closed loop mode available for this spatial multiplexing scheme. The closed loop mode is relying on UE feedback, and the open loop mode is beneficial at high mobile speeds where the UE feedback may not be reliable anyway. So then the base station can operate in open loop mode. An additional scheme used in LTE is called cyclic delay diversity. It is used in addition to spatial multiplexing as a further enhancement. An antenna-specific delay is added to the signal transmitted by each antenna, delaying the signal effectively, and this is done by a cyclic shift of the signal on each antenna. And this effectively results in an artificial multipath situation experienced at the receiver side, causing increased frequency diversity effect. Finally, beamforming can also be applied in LTE as well, which is especially relevant for the TD-LTE part. This picture illustrates the LTE downlink transmitter chain inside the base station. It shows the processing that is done for each code word that is output from the channel coding stage and what happens to it until the transmission over the antenna ports at the right hand side. So what is a code word? A code word is basically corresponding to a transport block. The transport blocks pass down from MAC layer to the for transmission over the physical layer, and the code word is an entity that has been channel coded by the turbocoder. In LTE you can actually have two code words in parallel that can independently be channel coded and then transmitted in parallel in case of the spatial multiplexing scheme. After scrambling and modulation of the code words, the MIMO layer mapping and precoding takes place. And that is the stage where it's actually decided whether transmit diversity or spatial multiplexing is applied, and which would result then in a different mapping and precoding operation specific to each MIMO mode. And also a wide range of configuration option exists at this stage. You have different precoding types depending on the radio channel characteristics, for example. Then the resulting signal out of the MIMO precoder is mapped on the OFDM time frequency resources for transmission on each antenna port. And again, LTE supports up to 4 transmit antennas at the base stations. Could also be 2, for example, depending on whether it's 2x2 or 4x2 or 4x4 MIMO. So now to better understand this layer mapping and precoding stage from the slide before, let's have a closer look on what happens in case of transmit diversity. So what is really done in these stages there of the signal processing, and the example shown here is for a 2 transmit antenna case. And it shows the space frequency block coding. So in case of transmit diversity, only one code word can be transmitted at once because we do not have spatial multiplexing. And the figure illustrates what happens to 2 symbols, D0 and D1, of that code word. First of all, these symbols are split onto 2 different layers in the layer mapper, and they are then pre-coded according to the space frequency block coding scheme, which is predefined in the standards. So the example shown here shows that the symbols are duplicated and then the conjugate complex signals, or even the negative ones, are transmitted according to a predefined rule. The resource element mapper defines how to transmit these symbols in time and frequency and over the antennas, and it's shown here that the same information is transmitted actually on both antennas because we have transmit diversity, but with different precoding. So antenna 1 in this example, TX1, transmits the symbol D0 at a certain subcarriers. At the same time, the antenna 2 transmits the symbol D1 on this subcarrier, with a special coding applied for this symbol. And looking at this other subcarrier, it's vice versa. TX2 transmits D0 and TX1 transmits D1. So actually we transmit a redundancy of information, but we achieve an increased robustness, but no increase in throughput or data rate compared to the single antenna case. So this is transmit diversity. Now let's have a look at the downlink spatial multiplexing operation in LTE, which again uses a codebook-based precoding. So what is a codebook? The codebook is actually for the 2x2 MIMO case shown here on the left-hand side, this table taken from the specification. The table effectively contains entries of precoding vectors and matrices, which are multiplied with the signal in the precoding stage of the base station. So now the selection which of these matrices or vectors to take, which codebook entry to select, is taken in the base station, and the decision is based on the regularly received UE feedback that the UE is providing. So the UE is of course estimating the radio channel and also evaluating the quality of the received signal, and based on that the UE recommends the optimum precoding matrix out of the codebook. The codebook is known of course at the base station and the UE side. And this feedback is called precoding matrix indicator, PMI, so the UE is actually pointing to one of these entries. And how is that done? So the UE is actually evaluating which precoding matrix would maximize the reception quality. Besides the PMI, the UE also reports CQI feedback, channel quality indication, and also a rank indication, RI, which provides information on the rank of the channel matrix. So that information will provide the base station with input whether spatial multiplexing or transmit diversity should be used. So this is downlink spatial multiplexing based on the codebook-based precoding as the other possible MIMO mode, and the base station has now the different configuration options available here. Finally, we look at the LTE uplink. There's no single user spatial multiplexing defined for the LTE uplink as we have seen for the downlink, and this is caused by the fact that the UE is not supposed to have two full RF transmit chains. But still the UE may have two transmit antennas and can switch the RF path between either one of them to exploit the diversity effect due to that. So the base station provides feedback to the UE which transmit antenna to use, and this is a closed loop scheme as well, so the scheme is optional for the UE to support. That's important to note, not all UEs have to support this. Another scheme used in the uplink is the so-called multi-user MIMO or collaborative MIMO, supported in LTE, so two UEs actually transmit simultaneously over the same time frequency resources. That is indicated in this small picture, and the UEs are actually scheduled by the base station, so the base station needs to decide whether this is actually possible or not. And each UE just needs to have one transmit antenna in this case, as it's also indicated in this picture. But you can imagine that this scheme only works in certain radio conditions, so it's really up to the base station to evaluate that carefully. Multi-user MIMO enhances the capacity, as you can imagine, because you exploit the radio resource twice by sending different UEs over these radio resources, and the users share the same radio resources. So the base station has to distinguish the users again, and that is done by different reference signals that are assigned for the different UEs.